Hello everyone. So today we're going to be talking about brain-computer interface and how so much of that is interconnected with bioengineering and how we can use computers today to help facilitate so much of physical activities applying to ourselves. So let's get started. Okay, so what is a BCI, or a brain-computer interface, which can also be known as a BMI, which is a brain-machine interface? Now, again, there's the question, have you ever wondered if you could control things with your mind? And through this device, now you can, to a certain extent. So let's dive right into it. So what is the technical definition of a brain-computer interface? Well, the technical definition is that it is a machine that uses signals from the brain and processes those signals and translates them into commands, where it is sent to an output device to perform an action. So really, you're using those electrical signals that your brain delivers, and it is then transformed or transferred to a device in the external environment to cause or perform some type of action based on what your desired reaction was. So one of the goals for this study is that through BCIs, scientists are hoping to be able to use this as a way to perform or facilitate physical functions for people that have impairments. For instance, if you have an amputation or someone with a disabled leg, or someone who has dementia, Alzheimer's, and so many other possibilities that BCIs can actually potentially impact. So this is still a relatively new field of study, but under the certain restraints and performance that it has been able to already experiment on, it has shown positive reactions that perhaps BCIs is the future of what we would like to do with many of our processes going forward. So how does it work? Now, BCIs are exclusively only able to analyze the information in the central nervous system of the brain, of your body. So essentially, the CNS, otherwise known as the central nervous system, is composed of the brain and the spinal cord. Now, there is another system called the peripheral nervous system, or the PNS, which extends from the CNS but also relates to the muscles and organs. So in this case, our BCIs that we will be focusing on, and BCIs exclusively, they in general can analyze the information that they collect exclusively from the central nervous system. So as you can see, there is a very nice diagram of both of the two systems, and you can tell which one is which because of the differences and what they do cover. Now, how it works continued is that one thing that you have to keep in mind is that just taking in signals or analyzing signals does not make a device a BCI. BCIs are a two-part system, okay? So taking in electrical signals from the brain is part one. Let's break it down and let's say that's part one of its job. So, for instance, you can use an EEG, which records electrical activity of the brain, and that's usually non-invasive. So those are used to record such activities, but just an EEG on its own is not a BCI because you're not doing anything to impact your external environment. Now, there is also part two, which is using those signals, so taking in the signals that you have just received from your brain, almost like taking in a command, and using that command to transform into an output. So there's the idea of having an order, an instruction. So if you think of it as a computer, there's an instruction phase where your brain is giving a certain instruction, and then there's the output of what that instruction should look like in reality. So essentially, that's what the BCI does. It's a two-part system that, one, takes in electrical signals from the brain, and two, analyzes those signals so that it may perform some type of desired output as needed. For instance, such as a wireless prosthetic limbs, which we will talk a little bit more about, and how a BCI can help with the function and mobility of such a thing without the use of external or internal wires. Now, there's a slight disclaimer at the bottom of this slide, and it's in part it's a joke, but in a serious sense it's not. So the disclaimer is BCIs are not mind-reading devices. Now, you may think that this is an obvious idea of why would you need to restate something that seems quite obvious, but in a certain sense, because this is still a relatively new field of study, there are so many ideas going out saying that BCIs could have an ulterior motive or could have some otherwise negative or detrimental impact, or somehow a violation of ethics in terms of privacy. Well, to be honest with you, a BCI cannot necessarily take in those mental ideas or mental thoughts and emotions and transfer it somewhere else, because BCIs are essentially just analyzing signals. Okay, so they're not reading your mind per se. They're literally just taking in sets of instructions that your brain is sending through its nervous system, and then it's outputting it through the device and for a certain desired reaction. Alright, as you can see, here's an example of how that system would work. So as you can see, it's a signal processing closed loop system where your brain, essentially the BCI chip, acts like the nervous system for that prosthetic limb. So your nervous system controls your movements and the BCI controls the movements of the prosthetics. Alright, so there's two common ways of use. Now, one is an invasive procedure, which is essentially where you would have to perform a procedure through which a chip will need to be inserted into your brain, which will help pick up the electrical signals and info and will be transferred to the output device, such as a prosthetic. Now, there is also a non-invasive way of doing it, and that is through the use of EEGs, which essentially place electrodes on your scalp, and that's how they measure those electrical signals. Now, both of these situations, regardless of which one is utilized with a patient, both of these situations require a certain period of learning and training. So, for a patient to fully acclimate to the use of a BCI, it's not a one-day procedure where the doctor performs the procedure and the patient is ready to go with their newly bioengineered limb or device. Instead, it is something that is somewhat of a learning curve, because the machine needs to get, it's sort of like AIs, where the machine needs to understand the user and the user needs to understand the machine. And in doing so, you build this relationship between the machine and the user, where the user will slowly become adjusted to what it is that they can do and cannot do, and the limitations and how to perform their desired actions. For instance, a person with a prosthetic could end up using their prosthetic hand, let's say, to play chess. Now, chess, obviously you have tiny pieces on a board, so it does take some fine motor skills to be able to take your prosthetic hand and have that precise way of picking up a piece and placing it somewhere. And to do that, it's not something that a person is, let's say, born with the knowledge of how to do. So instead, what they do is they end up having a training period during which the patient is given time to use their BCIs and prosthetics together and get used to the way of how it works and how they should be able to process these commands, and what commands will perform or provide what action or reaction. As you can see, here are the two common ways. So as you can see right here, this is the non-invasive way. Essentially, it's something as you would see out of a sci-fi movie, where you have these electrodes protruding out of your scalp or head or skull. And here is the invasive procedure, where you would literally have a chip inserted into a certain region of your brain. And that is how both of these systems, although they're different, they both have a similar way of processing information, because the purpose of both of them is to gather those signals and to analyze or pick up those data for analysis. Alright, so certain implementations that are associated with BCIs. Now, this topic of research has gained traction in recent times, so this has become something that many researchers are now focusing on, because it does have a potential to provide a lot of beneficial opportunities for patients of many different kinds of impairments. So one of the many there are multiple situations in which BCIs can be used, and here are a few examples of those, including prosthetics for amputees, neuromuscular disorder, cerebral palsy, and memory issues with older populations, dementia and Alzheimer's. So these are all something that can be helped, well, that has a potential of being helped through a BCI. So going through with this, there have been several research practices out there that have started to look into this, and one of them that I would like to bring up is this research done by the published by the Association of Academic Physiatrists, in which they convey the controlling of a prosthesis through your brain of the lower extremities. So essentially what they conveyed was how they were able to help a patient acclimate to using a prosthetic knee, especially one whose knee had been amputated. Now, one of the ways that they go about doing it is almost like a computer programmer would go about debugging a program, where they build up the pieces or build up the processes from simple, and then they take those simple pieces and combine them together. So essentially, one of the first things that they do is they don't just automatically say, let's practice kicking with your leg, with your new prosthetic leg, or let's practice something that's extreme, such as running. Instead, what they have them do is essentially just sit-ups. You sit up, sit down, get up, get down, things like that, just to help that patient understand how their knee was locking and unlocking. Because in our natural body, we have a patella, and we have sockets, and we have joints, and we have so many other things. But when you have a prosthetic leg or a knee, it's sort of almost as if you are part of your body is out of your control. And essentially the BCI process is trying to find ways, especially in this experiment where this one patient who had their amputation and wanted to go through with this BCI process, one of the things he wanted to do was be able to carry his daughter in his arms. And so to build up to that process, what they ended up doing was they ended up practicing walking up and down. Then they moved on to walking on inclined surfaces, because as you can imagine, it's not something that we take for granted, but once we learn to use something like a BCI, you sort of have to imagine how difficult it would be to maneuver your part of your body that's not necessarily entirely in your control. So again, things like this, that's how most of these things are built up, in that BCIs, although they seem very difficult to understand or seem very complex in the sense of implementation, they are not so, especially when given the time to acclimate, given the time to practice with them. Again, here are some images conveying how an invasive procedure would look like and how a person would go about seeing it through a CT scan. And that would be what a chip would look like right here. So there was a second research, and this one was slightly different. So it's not only focusing on prosthetics, but this time it was also focusing on just the brain as a whole. So BCIs, as I've mentioned, they are not only used for prosthetics, but they have so many other uses, including helping with memory loss or dementia or Alzheimer's. And one of the things that came about was this research here that was published by the Frontiers in Neuroscience dealt with a study focusing on how BCIs could potentially improve the quality of life for older adults, especially those who are going through a period of where they might have been diagnosed with dementia, or they are experiencing things such as slight to major memory loss. And essentially, the way that the BCI would help them is by using the neuroelectrical signals and deal with the brain shrinkage, because oftentimes as a person grows older and as the body grows older, the brain tends to end up shrinking. And because of that, the BCI can actually help in the sense that they are providing a way of helping not only monitor the electrical signals, but also monitor the changes within the brain. And this is what this research focuses on, how we can use BCIs to provide that option of using the brain signals as a research to show early indications of dementia or early indications of Alzheimer's, and see if there is any way we can utilize the BCI to provide, let's say, reminders or electrical triggers, which would then help the patient not regress as swiftly as they would have, let's say, without a BCI. Again, here is another concept that was also prevalent in that study, was the concept of using the EEG, which is a non-invasive way of capturing electrical signals, and using that to decrease the debilitating dependence of the elderly. So, for instance, what they were suggesting was utilizing a BCI to actually provide control to external things, not only, let's say, limbs, but external things such as using that to control your movements, but also movements of, let's say, a TV or your home appliance or other tech things that could be utilized to, let's say, help the elderly not put so much pressure on their brain, but also be able to focus their memories and their brain power on other things. Now, future implications. So what does this mean in terms of what a future of this would look like? So many researchers have suggested that, if BCIs do have a potential of being the thing we're looking at for the future, then essentially so many things can now become possible, including hands-free texting with your brain, or controlling the TV mentally, or internal search engines. So the sky is the limit. But just like with every positive, there is some negative. In this case, there is a negative in the sense that, can you imagine how detrimental it would be to, let's say, drive while you're mentally texting someone? Because as we all know, trying to multitask, especially with driving, something that's very serious, that not only impacts you but so many others around you, that your brain, you should not be dividing your attention in so many different multiple or different tasks at hand. So things like that is something that ethics officers or people who are involved in the ethics committees are looking at. To what extent do we let the study of BCIs go, so that should we be able to use BCIs for simple things such as changing the TV channel, or should we be able to use the BCIs for texting? What are the ramifications that go into this? So that's just a thought out there. So essentially, that is what a BCI is.